So today we'll be doing matrices in simultaneous equations. How do we solve simultaneous equations using the matrix method? We'll start with an example of 2 by 2 matrices. So if we've got a simultaneous equation that is 3x plus 4y is equals to 8 and 2x minus 5y is equals to 13. So how do we convert these matrices, these simultaneous equations into matrices? First of all, what we're going to do is we're just going to put brackets around it. So putting brackets around it, we get two matrices. Now what we're going to do is we're going to split this matrix into two matrices. What we're going to do is we're going to separate the constants, which is 3, 4, 2, and minus 5, and multiply them with the unknown terms, which are x and y, and then write the product as it is, which is 8 into 13. So what we now know is that we've got three matrices that can be solved easily by matrix equation method. So what you're going to do next is you're going to multiply the matrix with its inverse. For example, the matrix that we took that was 3, 4, 2, and minus 5, we're going to name it as A. So A matrix will be multiplied with its inverse, which means that A inverse will be multiplied with this, and then we'll write the entire equation as it is. But since we're multiplying the inverse on the left hand side of the equation, we're supposed to multiply the inverse on the right hand side of the equation as well. So this is what we get now. Through the background knowledge, we know that A inverse and A always gives us an identity matrix, and an identity matrix has no value. So our left hand side of the equation, we are left with xy is equals to A inverse. Now finding out A inverse, what we get is 1 over determinant, which is minus 15 minus 8, multiplied with its adjoint, which is minus 5, minus 4, minus 2, and 3, and 8 and 13, the product comes as is. Now what we're going to do is we're going to multiply our first two terms and then multiply the two matrices afterwards. So we get xy is equals to, we'll multiply the fraction first, we get 5 over 23, we get 4 over 23, we get 2 over 23, and we get minus 3 over 23. And we multiply this with our product, which is 8 and 13. Now multiplying these two, we finally get xy is equals to, we use the simple matrix multiplication method that we've been learning, xy is equals to 4 and 1. Therefore, our answers are x is equals to 4 and y is equals to 1. So this is how you solve a simultaneous equation through matrix method of 2 by 2 matrices. Now coming towards the next method, that is solving our simultaneous equations by 3 by 3 method. That is, for example, we've got a simultaneous equation that is 3x plus 2y minus z is equals to 4, and then you have minus 5x plus 3y plus z is equals to 4, and then you have the third equation as x minus y plus 8z is equals to 23. Now, following the steps for the matrix simultaneous equation in matrix form, what we're going to do is we're going to separate the constants. So we get 3, 2, minus 1, minus 5, 3, 1, 1, minus 1, and 8. This is going to be multiplied with our unknowns that are x, y, and z, and we finally get our product that is 4, 4, and 23. Now, following the state methods, what we're going to do is we're going to multiply it with A inverse on both sides. We multiply this with A inverse and we multiply the right hand side with A inverse. So multiplying this with A inverse, we get an identity matrix which has no value. So our equation now becomes x, y, z is equals to the inverse of 3, 2, minus 1, minus 5, 3, 1, 1 minus 1, 8, multiplied with our 4, 4, 23. Solving these two matrices by our matrix multiplication, what we're going to get is x, y, z is equals to 1, 2, and 3. Therefore, our x is 1, our y is 2, and our z is 3. In order to recheck our answers, what we're going to do is we can even check our answers by solving these simultaneous equations like we've learned before in our O levels or IGCSE. So you're going to simply solve the simultaneous equations and you're definitely going to get the same answer as our matrix multiplication method. So that's all for today. This is all that we've got under the heading of simultaneous equations through matrix method.